something has stayed with you. The feeling, maybe once, maybe only in a dream, that you were watching yourself from somewhere else. The science of that sensation is stranger than the experience itself. What feels like the soul stepping free is actually a specific region of the brain losing its grip on where the body ends and the world begins. And the part most people miss. It does not require sleep, or drugs, or a near-death moment. It can be triggered in a laboratory, with nothing more than a rubber arm and a pair of electrodes. Welcome to Sleepy Science. Tonight begins where the body's map of itself starts to blur. Close your eyes and breathe slowly. You are already somewhere between here and wherever that other place is. Let the question rest. Now we begin. The out-of-body experience has a name in neuroscience. Autoscopy. It refers to the perception of seeing one's own body from an external vantage point, as though a second self has drifted slightly upward and turned to look back. Reports of this experience appear across every culture and recorded period of human history. In Egyptian funerary texts, in medieval Christian mysticism, in the near-death accounts collected by cardiologists in intensive care units. What changed in the late 20th century was the shift from testimony to measurement. Researchers began asking not what people believed was happening, but what the brain was doing at the moment the self appeared to leave. The answers that emerged were as strange as the experience itself, and considerably more unsettling to certain assumptions. The parietal lobe sits at the top and back of the brain, roughly beneath the crown of the skull. Its primary work is integration, assembling signals from the eyes, the inner ear, the skin, the muscles, and the joints into a single, coherent sense of where the body is in space. Neurologists call this proprioception and vestibular processing, but in practice it amounts to something simpler. The continuous, automatic answer to the question, where am I and which way is up? When this process runs smoothly, it is invisible. You do not feel yourself locating your body. You simply are where you are. The out-of-body experience begins. Current evidence suggests when that assembly process briefly fails, 3 signals arrive simultaneously at a small region of the brain where the temporal and parietal lobes meet, just above and behind the ear. One comes from the eyes. One comes from the body's position sensors in the muscles and joints. One comes from the fluid-filled canals of the inner ear. The brain's job at this junction is to reconcile these 3 streams into a single answer. Where am I? And which way is up? Most of the time the answer arrives seamlessly. But when the 3 streams carry conflicting information, when the eyes report one thing and the body sensors report another, the junction produces a perceptual error. That error, the evidence suggests, is the out-of-body experience. In 2002, neurologist Olaf Blanke and his colleagues at Geneva University Hospital were performing electrical brain mapping in a patient preparing for epilepsy surgery. They needed to identify the function of specific cortical regions before removing tissue. They delivered a mild electrical current to the right temporoparietal junction. The patient reported something unexpected. She felt herself floating upward toward the ceiling and could see her own body lying below on the operating table. When the stimulation stopped, she returned to normal. When it was reapplied, the experience returned. This was the first time an out-of-body experience had been deliberately induced in a clinical setting, and the electrode had touched a precise, mappable point in the brain. Blanke's 2002 finding was later replicated and expanded in a 2006 study published in Nature, examining 6 patients with epilepsy who reported spontaneous out-of-body experiences. In each case, the experiences were associated with seizure activity in the right temporoparietal junction. What was notable was the specificity. These were not generalized perceptual disturbances or hallucinations of other kinds. The patients reported a consistent set of features: elevation, looking downward, recognizing their own body below. The proposed mechanism was multisensory conflict. The temporal lobe's vestibular processing generated a sensation of upward movement, while proprioceptive signals still anchored the body to the bed. The result was 2 simultaneous but incompatible locations for the self. The rubber hand illusion is a well-established demonstration of how easily the brain's sense of body ownership can be manipulated. In the standard version, a person rests one hand hidden from view, while a rubber hand is placed visibly before them. A researcher brushes both the real hand and the rubber hand simultaneously. Within minutes, most people begin to feel that the rubber hand is their own, even though they can see it is made of rubber. The brain resolves the conflict between visual and tactile signals by choosing ownership of what it can see. This simple experiment demonstrates that the self is not a fixed property of the body. It is a construction, and a fragile one. Researchers have used virtual reality technology to produce full-body versions of the rubber hand illusion. In a 2007 study at University College London, participants wore head-mounted displays showing a camera feed of their own back, positioned 1 to 2 meters in front of them. A researcher then stroked both the participants' actual back and the virtual back shown in the display. Within a few minutes, participants consistently reported feeling that their self was located in front of them, at the position of the virtual body, rather than inside their physical body. When a threatening object was moved toward the virtual body, the participants' skin conductance spiked, indicating genuine fear for the location they now perceived as their own. The vestibular system is among the oldest sensory systems in vertebrate evolution. It detects rotational movement and linear acceleration through fluid motion in the semicircular canals and otolith organs of the inner ear. For most animals, and for most of human history, it operated alongside vision and proprioception without significant conflict. The modern sleeping human presents a novel condition. Eyes closed, body motionless, but dreaming, the brain generating visual and kinematic experiences with no correspondence to the stationary body. Sleep researchers have proposed that out-of-body experiences at sleep onset represent this mismatch. the vestibular system begins its transition to rest, while some circuits remain alert enough to register the gap between what the body is doing and what the brain expects. Out-of-body experiences are considerably more common than most people realize. Survey data compiled across multiple countries consistently places the lifetime prevalence somewhere between 5 and 10% of the general population. Some studies, using broader definitions that include hypnagogic episodes at sleep onset, report rates closer to 20%. The experiences are not associated with any particular psychiatric condition. They occur in individuals with no neurological history, in healthy young adults, in people who have never used psychedelic substances, and in people who have never had a near-death event. The primary predictors are sleep disruption, high dissociative tendencies within the normal range, and a history of migraine with aura, all of which share one feature: altered multisensory integration. Sleep paralysis is the condition in which a person wakes from REM sleep with consciousness restored, but the motor paralysis of dreaming still in effect. The body cannot move, but the mind is alert. This state affects a significant minority of the population regularly, and most people at least once. It is among the most reliable natural triggers for out-of-body experiences. The mechanism appears to involve a disconnection between the brain's proprioceptive model of the body and the incoming signals from the paralyzed muscles. Receiving no motor feedback and no confirmation of where the body has moved, the brain may default to generating a kinesthetic experience of movement, of floating, of rising, from internal signals alone. The phenomenon of heautoscopy is a more complex variant of the out-of-body experience, in which a person does not simply observe their body from outside, but perceives a double, a second version of themselves, visible in the room. This occurs in a small subset of neurological cases, most frequently associated with epilepsy and migraine, and occasionally in acute psychiatric presentations. The perceptual and emotional character of heautoscopy is typically disturbing in a way that the standard out-of-body experience is not. The experiencer often cannot determine which body is the real self, and some describe a profound uncertainty about where they actually are. Neurologically, it likely involves a bilateral disruption of the temporoparietal junction, rather than the unilateral right hemisphere pattern seen in classic otoscopy. Ketamine, an anesthetic that blocks NMDA receptors in the brain, reliably produces out-of-body experiences at sub-anesthetic doses. Ketamine's primary effect at these doses is a disruption of multisensory integration, particularly in the circuits involved in building a coherent sense of spatial self-location. NMDA receptors are heavily concentrated in the temporoparietal junction and surrounding association cortex. When their activity is suppressed, the brain's ability to reconcile conflicting sensory streams degrades in exactly the way Blanke's model predicts. A single pharmacological agent, targeting a specific receptor type, reproducibly generates the full experience, the elevation, the external viewpoint, the sense of looking down. This is considered one of the stronger pieces of evidence for the neurological account. And yet the mechanism may not be the whole of the story. The near-death experience is the cultural context in which out-of-body experiences are most widely discussed, and it presents the most persistent challenge to purely neurological interpretations. People who report near-death experiences consistently describe leaving their body, observing resuscitation attempts from above, moving through a tunnel toward light, and encountering deceased relatives. These accounts share structural features across cultures and belief systems. Cardiologist Pim van Lommel published a prospective study in The Lancet in 2001 following 344 cardiac arrest survivors. Of those with a verifiable near-death experience, a small number reported accurate observations of their resuscitation environment during periods of confirmed cardiac flatline. This remains among the most methodologically careful evidence on the subject, and it remains genuinely contested. The AWARE study, conducted by cardiologist Sam Parnia and colleagues across multiple hospitals in the United States and United Kingdom between 2008 and 2012, attempted to test out-of-body claims directly. Shelves were installed near ceilings in resuscitation areas, each holding a randomly selected image visible only from above. Of the 152 patients who survived cardiac arrest and were interviewed, 2 reported out-of-body experiences. 1 was resuscitated in a room without a shelf. The other reported an experience consistent with accurate observation of the resuscitation room, though the shelf target in that room was not confirmed. The study is cited both as failing to verify the out-of-body hypothesis and as providing a single suggestive case that warrants further investigation. The brain continues generating experience during general anesthesia in a small but measurable fraction of cases. This phenomenon, called anesthesia awareness, occurs in roughly 1 to 2 per 1,000 surgical patients and typically involves auditory experience without the ability to move or respond. Occasionally, it includes visual experience. The distinction matters for the neurological model. If a patient accurately reports visual details of their surgery from an external vantage point, this cannot be explained by ordinary sensory processing, since the eyes are closed. Whether these cases reflect genuine extrasensory experience or some form of non-standard sensory access through indirect cues remains an open scientific question, investigated with somewhat more rigor than the topic typically receives. Researchers studying out-of-body experiences have paid increasing attention to the default mode network, the set of brain regions most active during rest, self-referential thinking, and mind-wandering. This network includes the medial prefrontal cortex, the posterior cingulate cortex, and the precuneus, all of which contribute to what researchers call self-referential processing, the brain's ongoing modeling of who and where the self is. The precuneus, in particular, is associated with first-person visual perspective and the sense of agency, the feeling that I am looking out from here, rather than from somewhere else. Disruption of the precuneus, whether through lesion, electrical stimulation, or certain dissociative states, consistently shifts the felt perspective of self-location. The practice of deliberately inducing out-of-body experiences has an extensive tradition in contemplative and esoteric contexts. most notably in the literature of astral projection. Documented in theosophical texts from the late 19th century and later systematized by researchers like Robert Monroe, whose Monroe Institute in Virginia has trained practitioners in out-of-body induction since the 1970s. The techniques converge on a consistent set of methods. Entering a state of physical relaxation while maintaining mental alertness. Attending to subtle hypnagogic sensations at sleep onset. And attempting to amplify vestibular sensations. The sensation of rolling, floating, or vibrating, to the point of full perceptual separation. From a neuroscientific standpoint, these are methods for deliberately entering the sleep-onset multisensory mismatch state. The hypnagogic state, the transitional zone between waking and sleep, is characterized by a particular kind of neural activity in which conscious awareness persists, while motor control and sensory filtering begin to relax. Electroencephalographic recordings from people in hypnagogic states show a mixture of alpha and theta waves, with brief interruptions of REM-like patterns. Muscle tone is reduced, but not fully suppressed. The vestibular system is beginning its transition, generating subtle sensations of movement in the absence of actual movement. Proprioceptive signals from the muscles are softening. For a brain that relies on the agreement of these systems to locate the self, the hypnagogic state is precisely the condition in which out-of-body experiences are most mechanistically plausible. A 2019 study from the University of Ottawa surveyed undergraduate students about their sleep habits and out-of-body experiences. Contrary to the expectation that these experiences are rare curiosities, fully 17.8% of the sample reported having had at least one experience of watching themselves from outside their body. Within that group, a significant portion reported the experiences occurring specifically at sleep onset, and another large portion reported them occurring during sleep paralysis episodes. The study also found that individuals who reported chronically irregular sleep schedules had elevated rates, consistent with the hypothesis that vestibular proprioceptive mismatch during disrupted sleep onset is a primary driver of naturally occurring out-of-body experiences in healthy populations. The corpus callosum connects the two hemispheres of the brain, allowing them to share information and maintain a coherent, unified experience of the self. Research on split-brain patients, people who had their corpus callosum severed to treat severe epilepsy, offers an unusual window into what happens when the two hemispheres cannot coordinate. These patients, studied extensively by Roger Sperry and Michael Gazzaniga from the 1960s onward, can, in some conditions, appear to have two semi-independent streams of consciousness. The left hemisphere, handling language and verbal reasoning. The right hemisphere handling spatial and non-verbal processing. The right hemisphere's specialized role in spatial self-location and body ownership may partly explain why out-of-body experiences are so consistently associated with right hemisphere disruption rather than left. The insula is a folded region of cortex buried beneath the frontal and temporal lobes. It integrates signals from the body's interior, heartbeat, breathing, gut sensation, temperature, into what researchers call interoception, the felt sense of the body from within. The insula's contribution to self-location is distinct from the temporoparietal junctions, where the junction builds a map of the body in space. The insula builds a map of the body as a living organism, from the inside. Disruptions to insular activity are associated with a particular variant of depersonalization, not the sense of floating outside the body, but the sense of the body becoming distant, unreal, or no longer quite belonging to the self. Depersonalization disorder is a persistent condition characterized by feeling detached from one's own thoughts, feelings, and body, as though observing oneself from outside, or as though the self is not quite real. It affects an estimated 1 to 2% of the population in clinically significant form and is considerably more common as a transient experience. The neurological signature of chronic depersonalization includes reduced activity in the insular and temporoparietal junction, alongside heightened prefrontal activity that may represent a form of emotional suppression. In contrast to the out-of-body experience, which is typically vivid and spatially specific, depersonalization tends to carry a quality of emotional flatness, presence without aliveness. The mechanisms overlap but are not identical. The otolith organs, the utricle and saccule, detect linear acceleration and the pull of gravity. They are the instruments by which the brain knows which way is down. When a person lies still on their back, the otoliths confirm a consistent signal. Gravity pulling in one direction, body pressed against a surface. During certain stages of falling asleep, however, the brain's interpretation of these signals can shift. Some sleep researchers have proposed that the myoclonic jerk, the sudden muscle twitch that often accompanies sleep onset, is triggered by a momentary otolith signal interpreted as a fall, to which the motor system responds reflexively. The same signal, interpreted differently in a state of more preserved consciousness, might instead be experienced as a sudden ascent. Tibetan Buddhist practice includes a specific tradition called dream yoga, in which practitioners work to maintain awareness during dreaming and, in advanced forms, during the transition between sleep and death. Certain instructions within this tradition closely parallel the neurological description of inducing out-of-body experiences. Maintaining a relaxed body while keeping a thread of conscious awareness alive. Attending to vibratory or kinesthetic sensations that precede the experience. And practicing non-attachment to the specific location of awareness. Researchers collaborating with Tibetan monastic institutions have studied advanced practitioners using sleep monitoring equipment and found unusual patterns of gamma wave activity during practices that the practitioners describe as involving deepened, boundary-dissolving awareness. The convergence between contemplative report and neurological measurement remains an active area of inquiry. The first 25 facts have outlined a pattern. The out-of-body experience. Across laboratory induction. Neurological lesion. Sleep disorder. Near-death event. And contemplative practice emerges from the same underlying mechanism. A disruption in the brain's multisensory model of where the body is and who is inside it. The right temporoparietal junction integrates signals that, when they agree, produce the seamless, invisible experience of being located in a body. When they conflict, the system generates a solution, and that solution is sometimes a self that appears to be somewhere else. What this pattern does not yet answer is why the experience so consistently feels like the most real thing the person has ever experienced. That is the particular disruption this script keeps returning to. Something is moving through you right now. The slow shift your body has been making since you lay down. The fact settling into something quieter than thought. A gentle subscribe lets another restless mind find this quiet place too. Breathe here with us, one sleepy soul at a time. Right now, the signals traveling from your inner ear to your brain are confirming exactly where you are. The otolith organs in the floor of your ear canals are pressing their tiny crystals against their membrane, and the message they are sending is simple. Still, level, resting. Your brain is receiving that confirmation and agreeing. But what the next facts follow is the question of what happens when that confirmation begins to arrive with something that doesn't match. When the inner ear says one thing and the body's position sensors say another, and the brain, caught between two truths, has to choose. Notice the weight of your body against the surface beneath you. That weight is the agreement the system is maintaining right now. Now we continue. The multisensory conflict model makes a specific prediction. Any condition that disrupts the agreement between visual, proprioceptive, and vestibular signals should elevate the likelihood of the out-of-body experience. Migraine with aura disrupts cortical processing across multiple sensory modalities. Epileptic activity in the temporal lobe distorts sensory integration. Sleep deprivation impairs the top-down regulation that normally resolves multisensory conflicts. Psychedelic compounds disrupt NMDA-mediated signal integration. Each of these conditions has an elevated association with out-of-body experiences, and each maps onto the same underlying mechanism. The convergence is the kind of evidence that accrues from very different methods, all disrupting the same system. Beyond self-location, a closely related phenomenon involves the feeling that someone else is in the room, just out of sight. In a 2014 paper published in Science, Blanky and colleagues showed that mild electrical stimulation of the sensorimotor cortex and insular regions in epilepsy patients produced a reliable report of a felt presence. A shadowy figure behind them, matching their own posture, following their movements. The patients knew the figure was not real, yet the sensation was compelling and, for some, frightening. In Blanke's model, the felt presence is a variant of the same error, the brain generating a second self-representation that has been misplaced in space. Proprioception, the sense of where the body's limbs are positioned, depends on specialized receptors embedded in muscles, tendons, and joints. These are among the fastest conducting sensory fibers in the nervous system, delivering position information to the brain with minimal delay. During normal movement, proprioceptive signals update the brain's body map continuously, confirming that the body is doing what the motor system commanded. During immobility, particularly the profound immobility of sleep paralysis or deep relaxation. These signals slow dramatically because there is no movement to report. The brain's body map, deprived of its normal continuous update, may begin to drift. Some researchers suggest this drift is the substrate from which the out-of-body experience constructs its alternative self-location. Tunnel vision and the perception of moving through a tunnel toward light, perhaps the most recognizable element of the near-death experience, may have a physiological basis rooted in the eye and the visual cortex. Under conditions of severe physiological stress, including cardiac arrest, the retina and visual cortex lose their peripheral input first. As blood flow becomes insufficient to maintain function in the metabolically demanding peripheral regions, what remains is central vision, producing the appearance of a bright central field surrounded by darkness. A tunnel. The motion through the tunnel may reflect the brain's attempt to interpret sudden changes in visual field illumination as movement in the absence of normal spatial context. Memory consolidation during sleep involves the replay of waking experiences in the hippocampus, a process that sometimes incorporates a spatial or positional component. Hippocampal place cells that map to location during waking life reactivate in sequence during slow-wave sleep. This spatial replay is normally invisible to conscious experience during deep sleep. In lighter sleep stages and in the hypnagogic state, however, fragments of this replay can enter awareness. Some researchers have proposed that certain out-of-body experiences, particularly those involving the sensation of flying over familiar landscapes, may involve the activation of stored spatial maps by the hippocampal system during this partial wakefulness state, producing vivid positional experience without any corresponding movement of the body. Damage to the right parietal lobe from stroke or tumor can produce dramatic failures of body schema maintenance. One result is hemispatial neglect, in which the patient ignores everything on the left side of space. Another is asomatognosia, the inability to recognize one's own limb as belonging to the body. These are not failures of vision or sensation in the affected areas. The limb still sends signals. The brain simply does not incorporate those signals into the self model. The out-of-body experience may represent a transient, whole-body version of this selective dissociation between signal and self. One of the more technically demanding experiments in out-of-body research was conducted by Henrik Ehrson at the Karolinska Institutet in Stockholm in 2007. Participants wore a head-mounted display showing a camera feed positioned behind them, creating the illusion that they were observing their own back from slightly outside and above. Ehrson then used a rod to tap the participant's real chest and another rod to tap the chest of the virtual body in the camera feed. In synchrone. Most participants reported feeling that their self was located at the position of the camera, outside and behind their actual body. When a threat was aimed at the virtual chest, the anxiety response confirmed that the brain had genuinely reassigned self-location. Traditional accounts of astral projection describe a silver cord connecting the traveling soul to the physical body, a feature that appears consistently across Western esoteric traditions, theosophical writings, and some Hindu texts. The silver cord serves the narrative function of ensuring that the traveler can return, and its breakage is associated with death. Neurologically, the silver cord has no known correspondent. But the concept may preserve something real. Many people who experience out-of-body states describe a persistent, subtle sense of bodily connection, even at the experience's most vivid. A background awareness of the physical body that persists alongside the dislocated perspective. This residual anchoring may reflect the portions of the body ownership network that remain integrated even during the disruption. The skin is the body's largest organ and one of its most important contributors to self-location. Mechanoreceptors in the skin deliver continuous information about pressure, temperature, vibration, and texture. The brain uses these signals, alongside proprioception and vision, to confirm that the body is where it appears to be. During profound relaxation, as muscles release tension and the sense of pressure from the surface beneath the body fades from awareness, cutaneous input decreases. Combined with reduced proprioceptive feedback and partial suppression of vestibular signaling, this reduction may contribute to the floating quality reported at sleep onset and during certain meditative states, a convergent diminishment of the signals that ordinarily anchor the self. G-force-induced loss of consciousness, experienced by combat pilots during high-acceleration maneuvers, can produce a specific form of out-of-body experience in the seconds before full blackout. As blood is pulled from the brain toward the lower body, the visual field narrows and consciousness fades. In that transitional zone, some pilots report seeing themselves from outside, observing their cockpit from an elevated perspective. Military aviation medicine has documented these accounts with enough regularity that they are considered a standard feature of G-lock events. They occur not during the loss of consciousness, but in the recovering phase, as the brain returns to partial function and the multisensory integration systems come back online in a disordered sequence. The posterior cingulate cortex is a region of the default mode network strongly associated with self-referential thought and the maintenance of autobiographical memory. It sits at a crossroads between spatial processing, emotional memory, and conscious self-awareness. Damage to the posterior cingulate can impair the sense of familiarity, the feeling that one's own memories and personal history belong to a continuous self. In neuroimaging studies of meditation and dissociative states, the posterior cingulate shows characteristic decreases in activity during experiences of self-loss or boundary dissolution. Some researchers have proposed that its quieting during deep relaxation may be a permissive factor in experiences that blur the boundary between self and surrounding space. The sense of self as a spatially located entity appears to require continuous maintenance. Studies using transcranial magnetic stimulation to temporarily suppress activity in the right temporoparietal junction produce mild but measurable changes in the sense of self-location. Not dramatic out-of-body experiences, but a subtle loosening of the certainty about where the self is. The same temporary suppression also reduces the accuracy of perspective-taking tasks, in which participants judge how an object looks from another person's viewpoint. The mechanism that keeps the self located in the body is the same mechanism used to project awareness into another body's perspective. Both functions share a common address: sensory deprivation environments, isolation tanks filled with skin temperature salt water, blocking light and sound, have a documented history of producing spontaneous, out-of-body experiences within the first hour. The mechanism aligns with the multisensory conflict model precisely. In the absence of visual input, with the body floating in water that matches its surface temperature, with minimal pressure differential between water and air, and with the head resting in near-total acoustic silence. The three systems that ordinarily triangulate self-location lose much of their input. The brain, receiving insufficient data to maintain its normal body location model, may generate its own. And that self-generated model may place the self somewhere other than where the body is. Thomas Metzinger, in his 2003 book, Being No One, and its more accessible follow-up, The Ego Tunnel, argues that the out-of-body experience demonstrates something fundamental. The sense of being a self located in a body is a model, a representation, rather than a direct perception of reality. The brain constructs a self-model and, in ordinary circumstances, presents it as the immediate, unmediated experience of being someone. The out-of-body experience is the moment when the model briefly fails to coincide with the body it is supposed to represent. What the experience reveals is not the soul, but the machinery. Before Tonight continues further. A distinction worth holding. Body ownership and self-location are, according to current research, two separable systems. Body ownership refers to the sense that this body, these hands, this torso, belongs to me. Self-location refers to where, within or near that body, the sense of I appears to be situated. The rubber hand illusion primarily captures ownership. The full-body virtual reality illusion primarily captures location. These two systems can be disrupted independently. Some out-of-body experiences preserve ownership. The person still recognizes the body below as theirs, while shifting location. Others seem to shift both, producing a genuine sense of alienness toward the body that was left behind. The question of whether consciousness can exist independently of the brain remains one of the most divisive in contemporary science and philosophy. The standard materialist position holds that consciousness is generated by brain activity and that out-of-body experiences are perceptual illusions produced by specific neural disruptions. An opposing position, associated with researchers like Pim van Lommel, Bruce Grayson at the University of Virginia, and the late Stanislav Grof, argues that the consistency and vividness of near-death experience accounts, combined with occasional verifiable accuracy, suggests that consciousness may operate under conditions current neuroscience cannot fully explain. Both positions are held by serious researchers. Neither has produced conclusive evidence that ends the debate. Both questions are worth holding. Neither one requires you to choose tonight. The experience of returning to the body, what out-of-body practitioners describe as where the transition outward is often smooth. Floating. Gradual. The return tends to be sudden. A snap. A jolt. A sensation of impact or descent. This asymmetry has a plausible neurological explanation. The disruption of multisensory integration that permits the out-of-body experience is self-limiting. As competing signals resolve, as proprioception and vestibular input resynchronize, as body ownership reasserts itself, the return to normal self-location is not a gradual correction, but an abrupt reintegration. The system snaps back to its default, and the transition is felt as a physical event. Research on out-of-body experiences and presence in virtual environments has converged around the concept of embodiment, the degree to which an avatar or virtual body is felt to be one's own. People with higher embodiment in virtual environments show stronger physiological responses to threats aimed at their avatar, and altered self-perception. Time distortion, changes in risk tolerance, and shifts in empathy toward characters they are embodying. The mechanisms that underlie full embodiment in virtual reality overlap substantially with the mechanisms that underlie normal body ownership, and by extension, with the mechanisms whose disruption produces the out-of-body experience. This convergence has made the out-of-body literature unexpectedly relevant to VR design and therapeutic applications. Clinical applications of the science of self-location are beginning to emerge. Chronic pain conditions, including phantom limb pain in amputees and complex regional pain syndrome, involve a malfunction of the brain's body schema, a mismatch between the body map and the actual state of the body. Virtual reality treatments for phantom limb pain deliberately manipulate the brain's sense of body ownership to reduce the pain signal, using the same multisensory conflict principles that underlie the rubber hand illusion. If the brain's sense of where the self is and what the body looks like can produce or alleviate chronic pain, the self becomes a clinical target, something that can be adjusted, not just observed. Cultural context shapes how the out-of-body experience is interpreted, though there is some evidence that the raw experience itself is more consistent across cultures than the frameworks applied to it. Western secular accounts tend to emphasize the perceptual strangeness and the ambiguity about what it means. Accounts embedded in religious or spiritual traditions tend to interpret the experience as confirmation of a soul, a spirit, or an afterlife. Indigenous traditions in the Americas, Africa, and Australia often include out-of-body travel as a recognized and cultivated capacity of spiritual specialists. The same raw percept carries very different meanings. What is consistent is not the interpretation, but the experience beneath it. The experience of time during out-of-body states is frequently reported as altered, either stretched, as though each moment expands, or entirely absent, as though time had simply stopped. This distortion is consistent with what is known about time perception more broadly. The sense of duration is constructed, dependent on the rate of neural processing, the density of event markers in working memory, and the activity of the insular cortex, which tracks bodily state changes that ordinarily segment experience time. In a state of profound dissociation from the body, with reduced interoceptive input. The mechanisms that build the experience of duration would naturally be disrupted, producing the characteristic timelessness that many people report as among the most memorable features of the experience. Acoustic cues play a subtle but measurable role in spatial self-location. The brain uses the tiny differences in timing and intensity with which sound reaches each ear to locate sound sources in space, integrating this information with the visual and vestibular stream. During periods of complete silence, or when sounds conflict with the proprioceptive sense of where the body is, this auditory contribution to self-location is disrupted. Some practitioners of deliberate out-of-body induction use binaural audio as a method of entraining the brain toward the loosened self-location state associated with out-of-body onset. Let that softness find you here, in the quiet that already surrounds you. The connection between out-of-body experiences and psychological dissociation has been studied with increasing rigor over the past 2 decades. Research consistently finds elevated rates of out-of-body experiences in people who score higher on the dissociative experiences scale, a standardized clinical measure, even within the non-clinical population. This association does not imply pathology. The scale measures a continuum and mild dissociative tendencies, daydreaming, absorption, the ability to become deeply immersed in an activity, are common and unrelated to disorder. But the association suggests that the neurological mechanisms underlying ordinary dissociative tendencies and the mechanisms that produce out-of-body experiences share common pathways, likely involving the same top-down regulation of multisensory integration. For some people, out-of-body experiences are deeply meaningful events that permanently alter their relationship to death, to the self, and to what they believe is possible. Survey research consistently finds that people who have had out-of-body experiences, particularly those associated with near-death events, report lasting reductions in death anxiety, increased compassion for others, and changes in what they consider important. These changes occur regardless of whether the person was religious or spiritual before the experience. The changes themselves are documented and not in dispute. What is contested is their interpretation. Whether they reflect a genuine encounter with something beyond the brain, or whether the profound alteration of self-model that the experience produces is itself sufficient to permanently shift a person's orientation toward the world. Halfway through these facts, something has quietly shifted in the question. We began with a disruption, a small electrode, a specific point in the right hemisphere, a brain temporarily losing its grip on where the body ends. The disruption is real and measurable. But the experiences it produces, the elevation, the clarity, the sense of finally being unbound, are not merely errors. They are among the most memorable and transformative events in a human life. The tension the second half of tonight follows is this. If the out-of-body experience is a construction of a failing brain, why does it so reliably feel like the most real thing? And what does it mean for the self that the machinery can be so easily freed? What just opened? The question of what it means that the most real feeling experience in many lives comes from a system that is briefly not working correctly, is not only a neuroscience question. You may be carrying something like that right now. The sense that something you have felt with great certainty, a fear, a judgment, a version of yourself, has been constructed rather than discovered. That's not a reason to distrust what you feel. That's where the second half of tonight goes. Notice where your body is in the room right now. Notice that you know, with a quiet, wordless certainty, exactly where you are. Now we continue. What makes an experience feel real, more real than ordinary waking life, is not answered easily by neuroscience. Researchers studying psychedelic experience have documented what they call noetic quality, a sense of encountering fundamental truth, of knowing something with a certainty that exceeds ordinary knowledge. This quality appears in high-dose psilocybin and DMT experiences, in meditative samadhi states, and consistently in out-of-body and near-death accounts. Its neurological correlates appear to involve the default mode network's temporary reorganization, combined with heightened limbic activation. The brain's meaning-making systems are operating in an unusual configuration. The experience feels more real, not despite the altered neural state, but partly because of it. DMT, N-dimethyltryptamine, is an endogenous compound found in trace amounts in human brain tissue and cerebrospinal fluid. It is also produced by numerous plants and has been used in shamanic contexts, most notably in the Amazonian brew ayahuasca, for centuries. When administered at clinical doses, DMT produces experiences involving entities, light, tunnels, and the sensation of leaving the body and entering another space. The experiences show structural similarities to near-death accounts that have generated serious research interest. Whether trace amounts in the human brain are sufficient to produce out-of-body experiences during extreme physiological stress remains genuinely unresolved. Hold that question lightly, without needing to close it. During deep meditation, the default mode network shows a characteristic pattern of decoupling. The normal synchronization between its nodes becomes looser, and the boundary between self-referential and perceptual processing blurs. Advanced meditators show this pattern in neuroimaging studies more consistently and at lower levels of effort than novice meditators. The subjective experience associated with this decoupling is described in contemplative traditions as non-self, the temporary absence of the sense of being a separate, located entity. It is distinct from the out-of-body experience, which typically preserves a located perspective. But both involve a disruption of the default mode network's maintenance of the self as a bounded, spatially specific entity. The experience of ego dissolution, the temporary loss of the sense of individual selfhood, is distinct from the out-of-body experience in an important way. In the out-of-body experience, the self is still present, it has simply moved. The I is still observing, still located. It has just relocated to a point outside the body. Ego dissolution, by contrast, involves the temporary absence of any located I, not self elsewhere, but no self at all. These are different failure modes of the same underlying system. Out-of-body experiences leave the self intact while relocating it. Ego dissolution dissolves the self while leaving the body in place. The temporal lobe, which sits roughly above the ears, is involved in the processing of complex sounds, face recognition, and the retrieval of semantic memories. In its right hemisphere portion, it is also associated with the experience of the uncanny, the sense of familiarity without recognition, or recognition without familiarity. Temporal lobe epilepsy is associated with a range of unusual perceptual experiences. Déjà vu, jamais vu, the sense of a presence, auditory hallucinations, and in some patients, full out-of-body experiences. The temporal lobe's proximity to the temporoparietal junction and its connectivity to limbic and parietal systems makes it a natural site where self-location disruption and emotional intensity converge. Research on cardiac arrest survivors has produced one of the more philosophically challenging findings in the study of consciousness. A 2023 study from NYU Langone Health, published in Resuscitation, monitored brain activity in cardiac arrest patients using electroencephalography. Some patients showed bursts of high-frequency gamma-wave activity associated with conscious awareness and perceptual binding during periods of cardiac flatline after the heart had stopped. These bursts occurred specifically in temporal and parietal regions. The study did not confirm any specific perceptual content during these periods, but it demonstrated that the brain can generate organized, awareness-associated activity in conditions previously assumed to preclude any form of consciousness. The phenomenology of the out-of-body experience is remarkably consistent across accounts that have no cultural connection to each other. Elevation, the external viewpoint, the recognition of the body below, the sense of clarity and calm. These features appear in accounts from medieval European mystics, 20th century cardiac arrest survivors, indigenous shamanic practitioners, and laboratory subjects in Geneva and Stockholm with no spiritual interest whatsoever. Consistency of phenomenology across conditions is typically treated in neuroscience as evidence of a common underlying mechanism. It also suggests that whatever the experience is, it is not principally a cultural construction. The cultural interpretations differ, but the experience beneath them does not. The emotional quality of out-of-body experiences is overwhelmingly positive in accounts that do not involve acute terror or medical emergency. Fear, when it occurs, is usually associated with the onset, the unexpected sensation of leaving the body before the person understands what is happening. Once the experience is underway, accounts tend to describe a profound tranquility, an absence of pain, an unusual clarity, and in some cases, a quality of love or connectedness that exceeds ordinary emotional experience. The brain's threat detection systems are, if anything, quieted during the out-of-body state. What is being turned down is not only the self's location, but something of its accumulated weight. Cases in which people at the bedside of a dying person report aspects of the near-death experience alongside them, sometimes called shared death experiences, are documented in the literature, though rarely. These accounts describe a bystander suddenly accompanying the dying person into a luminous space, sensing a presence, or perceiving the transition from an unusual perspective, before returning abruptly to the room. They have no accepted neurological explanation. They are studied by researchers at the University of Virginia's Division of Perceptual Studies. Whether they represent anomalous perceptual experience, grief-induced altered states, or something no framework yet fits, is genuinely unresolved. The precuneus, a wedge-shaped region on the inner surface of the parietal lobe, is involved in visuospatial processing, mental imagery, and the sense of being an agent with a first-person perspective. It is consistently active during episodic memory retrieval and shows reduced activity during dreamless sleep, anesthesia, and the vegetative state. Its activity level is one of the more reliable indicators of conscious awareness in clinical settings. Some researchers have proposed that the precuneus anchors the first-person visual perspective, the automatic processing that places the eye behind the eyes. When that anchoring fails, for whatever reason, the eye may find itself looking from elsewhere. The thalamus serves as a relay station for most sensory information traveling to the cortex, and it is a critical component of the consciousness maintenance circuitry. During normal waking, it continuously relays sensory signals to cortical areas that process and integrate them. During sleep, thalamic activity is suppressed in ways that reduce the cortex's access to sensory input. At the boundary between waking and sleep, in the hypnagogic state, thalamic relay is in transition. Some circuits are beginning to close, others remain open. This uneven shutting down may produce the patchwork sensory states characteristic of sleep onset. Some perceptions vivid, others absent, and the integrative machinery operating with reduced efficiency. Neuroimaging studies of experienced meditators during deep practice consistently show altered activity in the right temporoparietal junction. Specifically, a reduction in the activity associated with the distinction between self and other, and between self and environment. The meditators themselves describe this as a softening of the boundary of the self, a quality of openness or spaciousness around the sense of personal identity. The change is more subtle than an out-of-body experience. The edge of the self becomes less sharp, more permeable. The same region, disrupted more severely, produces the full relocation of self-location. The gradient from meditation to out-of-body experience may be a gradient along the same neural dimension. Out-of-body experiences reported by patients under general anesthesia present a particular challenge to the neurological model. These are not cases of near death. The patient is alive and stable. The eyes are closed. The brain is suppressed, and ordinary sensory processing is unavailable. And yet some patients accurately describe visual details of the surgical environment from an elevated or external perspective. These accounts are rare, and their accuracy is difficult to verify systematically. But they cannot be dismissed as sleep-onset hallucinations. They occur in a condition specifically designed to prevent conscious experience, and they describe a view of the room that the patient had no ordinary means of accessing. The sense of peace that characterizes many out-of-body and near-death experiences has attracted interest from palliative care researchers. If the dying process reliably produces a neurological state associated with the tranquility described in these accounts, this has implications for understanding what death feels like from the inside. Cardiologist Pim van Lommel has argued that the consistency of positive near-death experience reports across cultures suggests that the dying brain generates an experience that is, for many people, not frightening, but profoundly comforting. This does not resolve the question of whether consciousness persists after the brain stops, but it does soften a particular fear, that dying is predominantly painful and terrifying. The precuneus and posterior cingulate cortex together form what some researchers call the core of phenomenal consciousness, the neural substrate of the sense that experience is happening to a self, that the self is present, that the world is being perceived by someone. When both regions show reduced activity, as they do in dreamless sleep, anesthesia, and the vegetative state, the phenomenal sense of being present appears to be absent. When one or both show the altered activity pattern associated with multisensory mismatch, the phenomenal sense of presence may persist, but its location shifts. The self remains present, but it is present somewhere else. The frequency and character of out-of-body experiences change across the lifespan. Children between the ages of 4 and 8 report vivid experiences of watching themselves from outside during fever, illness, or night terrors at a frequency that appears higher than in adults. This may reflect the incomplete development of the temporoparietal junction's integrative functions, which are not fully mature until late childhood. Adolescents report the highest rates of sleep paralysis-related out-of-body experiences, consistent with the known peak of sleep paralysis in that developmental period. Older adults report fewer experiences overall, which may reflect changes in sleep architecture with age and greater habituation from a longer history of managing sleep-onset sensations. Derek Parfit, in his influential 1984 work, Reasons and Persons, argued that personal identity is less robust than we assume. That what we call the self is a sequence of connected experiences and memories, not a persistent substrate. On this view, the out-of-body experience does not raise a special problem for identity, because identity is already a construction requiring continuous maintenance. What the experience adds is evidence that the construction can be temporarily interrupted and then resumed, with no apparent gap in the person's sense of continuous selfhood. The out-of-body experience does not create the fragility of the self. It shows it, briefly, to the person who is carrying it. The auditory cortex continues to process sound during the early stages of sleep, longer than most other sensory systems remain active. This is believed to be an evolutionary feature. Sound detection has survival value even during sleep, and the brain maintains the capacity to alert on significant sounds while otherwise limiting cortical processing. Some practitioners of out-of-body induction report that specific sounds play a role in the onset of the experience, and that the transition out of it is often precipitated by sound in the environment. The auditory system, still open when everything else is closing, serves as a tether, the last thread connecting the drifting self to the room. The felt movement of the out-of-body experience, the rising, the floating, the sense of traveling, is typically described as different from physical movement. Physical movement is accompanied by proprioceptive feedback, vestibular sensation, and the effort of muscular contraction. Out-of-body movement is described as effortless, simply willing to be somewhere and finding oneself there, or being carried without resistance. This effortlessness is plausible neurologically. The movement is generated internally by the motor imagery system rather than the motor execution system, without the feedback loops that give physical movement its texture of effort and resistance. The brain can generate the experience of movement without any corresponding muscular event. Research on the out-of-body experience in populations with congenital blindness offers a useful test case for the model. If the experience is primarily driven by visual proprioceptive conflict, people who have never had visual experience might be expected to have different or absent out-of-body experiences. Studies with congenitally blind individuals who report out-of-body experiences find that the experiences are present, but described in non-visual terms. A sense of spatial displacement, of hovering, of perceiving the environment through non-visual senses from a displaced position. The experience is not fundamentally visual. The visual component, when present, appears to be added by the visual brain's attempt to model the displaced perspective. The experience of weightlessness, reported during the out-of-body experience as a quality of the dislocated self, is the normal result of the absence of otolithic input. Astronauts adapting to microgravity frequently experience altered self-location, the sense of being oriented differently in space, of the self placed in an unusual position relative to the body. Some report brief sensations of being above themselves during initial days of weightlessness, as the brain recalibrates without constant gravitational input. The overlap between the phenomenology of weightlessness and the phenomenology of the out-of-body experience is not coincidental. Both involve a disruption of the otolithic component of the multisensory self-location system. A consistent feature of near-death experience accounts is the panoramic life review, the rapid, non-linear retrieval of autobiographical memories, often described as simultaneous rather than sequential, accompanied by the sense of re-experiencing each moment from both one's own perspective and the perspective of those affected by one's actions. The neural mechanisms proposed invoke the hippocampus and the temporal lobe, which integrates memory with emotional and spatial context. Some researchers have proposed that brief hypoxia during cardiac arrest may trigger a release of stored memories in an unusually dense activation. Whether this is sufficient to produce the reported quality of the experience remains genuinely open. The philosophical position known as panpsychism, the view that consciousness is a fundamental feature of reality, not an emergent property of complex nervous systems, has gained renewed academic attention in recent decades. philosophers like David Chalmers, who articulated the hard problem of consciousness, and Philip Goff, who defends panpsychism in contemporary form, argue that the out-of-body experience and near-death accounts do not require a departure from materialism so much as a revision of what materialism means. If consciousness is a basic property of the universe rather than a late product of biological evolution, then questions about its location and extent take on a different character. The relationship between the out-of-body experience and lucid dreaming, dreams in which the dreamer is aware they are dreaming, has led some researchers to treat lucid dreaming as a laboratory model for out-of-body phenomenology. In both states, consciousness is present while the normal sensory anchoring of the self to the waking body is suspended. In both, the experiencer can navigate a space that feels real while knowing, at some level, that the physical body is elsewhere. The neural signatures of lucid dreaming include increased prefrontal activity and gamma wave activity, the same signature that Voss and colleagues found associated with reflective self-awareness during sleep. The brain builds a self from the agreement of its systems. Vision, touch, proprioception, vestibular sense, interoception, all send signals, and the brain constructs from their convergence an answer. Who is here and where when those systems agree? The self is invisible, seamless, obvious. When they disagree, the self becomes briefly visible. And what becomes visible is the fact that it was always a construction. The out-of-body experience is that construction's signature, left in the moment it fails. The remaining facts follow not the mechanism, but what the mechanism reveals. That the self is real, its location is real, and both are made from signals that were never perfectly permanent. Almost there now. Let your body rest a little more completely. Your proprioceptors are still sending their signals. The quiet confirmation of every joint, every resting muscle, every point of contact with the surface beneath you. The system is still at work, and all the signals are agreeing. You are here. This is where you are. Let everything else dissolve for a moment into that simple fact. We'll continue with the final facts. The self is not in the brain the way a thought is in the brain. It is more like weather, something that arises continuously from the interaction of many different systems, stable only as long as those systems are in sufficient agreement. The out-of-body experience is not the self escaping. It is the weather briefly becoming something else. And the weather, when it passes, returns to what it was. The right temporoparietal junction integrates what you see with what you feel, with which way is up. Most of the time, this integration is invisible. You do not feel yourself being located. You simply are located. The out-of-body experience is what happens when you briefly feel the process itself, the machinery that is always running, quietly, beneath every ordinary moment. The body owns the self the way the ocean owns a wave. The wave is real. Its motion is real. Its relationship to other waves is real. but it does not exist independently of the water from which it is made, and it does not persist when the water stills. The self is something like this, more real than its components, less permanent than it seems. People who survive out-of-body experiences near death tend to lose their fear of dying. Not because they are now certain of an afterlife, but because the experience showed them something about what the self is, that it is lighter than it appeared, less tied to the body's conditions than it seemed. What was frightening about death was the self disappearing, and the experience suggested that the self was never quite as solid as the fear required it to be. Every night, as you fall asleep, the signals that locate you in your body soften. The skin stops reporting. The muscles release their tension. The inner ear quiets. For a brief window, the brain holds a map of the self with no fresh data to update it. This is the threshold. Most people cross it invisibly, into sleep. A few, on certain nights, notice the crossing. The clarity reported during out-of-body experiences, seeing the room with unusual detail, thinking with unusual sharpness, is difficult to reconcile with the model of the experience as a failing brain. One possibility is this: the reduction in the continuous work of self-maintenance briefly frees resources for perception. The self is expensive. When it stops insisting on its location, something else becomes clear. The temporoparietal junction does something else, separate from self-location. It is the brain region most consistently active during tasks that require understanding another person's perspective, modeling what someone else knows or feels. The same region that locates the self in space is also used to project awareness into another space. The out-of-body experience, in this light, is not only a failure of self-location, it is the machinery of empathy, briefly turned on the self. The stars that produce the calcium in your bones died billions of years before the nervous system that experiences your body existed. The iron in your blood was forged in a collapsing star that has no name in any human language. What the brain calls the self, and carefully locates in a room, in a body, in a skull, is made of material that has been many other things. The body is an address, not the first address this matter has had. The out-of-body experience feels more real than ordinary waking life because the brain's self-monitoring and error correction systems have, for a moment, gone quiet. Ordinary experience has a background hum of uncertainty, the sense that what is perceived might be filtered, incomplete, or partly constructed. During the out-of-body state, that background hum is absent. The experience feels direct and unmediated. What is missing is not clarity. What is missing is the mechanism that ordinarily questions it. Consciousness researchers have begun to speak of the brain as a prediction machine, continuously generating models of the world and the self, revising them based on incoming sensory data. The out-of-body experience, on this model, is a prediction. The brain's best model of where the self is, generated when incoming data is reduced. The prediction persists because the brain has no better information to correct it with. And it feels real because all predictions feel real from the inside. The compassion that many out-of-body and near-death experiencers report gaining may reflect a genuine shift in how the temporoparietal junction processes the distinction between self and other. The experience temporarily collapsed the boundary between where I am and where you are. Something of that collapse persists afterward, not as a memory of a lesson, but as a change in the underlying processing. The boundary, for a moment, shown to be constructed, remains afterward slightly less insistent. Children as young as 3 report the experience of looking down at their own sleeping body. They use words like floating, up high, watching, words they were not taught for this. They are finding language for something that happened. Their descriptions match the accounts of cardiac arrest survivors, meditators, and epilepsy patients who have no connection to each other. The experience occurs in children who have no framework for it, no spiritual teaching, no knowledge of any literature. It is not a belief. It is a percept. The moment of waking from an out-of-body experience is described as a return, but what has returned is a sense of specificity. The self is once again precisely here, in this body, in this room, with this weight and this breathing. The specificity that felt confining before the experience feels different afterward, because it was briefly, vividly absent. And then it was here again, and that here carries a quality of arrival that ordinary waking never quite delivers. The brain's default mode network quiets during dreamless sleep, certain depths of anesthesia, and focused attention. It activates during mind wandering, self-reflection, and the imagining of other times and places. In some sense, it is the network that carries the self when the self has nowhere specific to be. The out-of-body experience is its brief failure to maintain a coherent address. But the failure is also, for those who experience it, a glimpse of what the network is always doing in the background, carrying the story of a self through time. People who practice meditation regularly are somewhat less likely to find the out-of-body experience distressing. Not because they have been told it is safe, but because they have prior experience of the self becoming less insistent, of awareness persisting while the usual sense of being a particular person in a particular place softens. On that background, the out-of-body experience does not feel like falling. It feels like a version of something that has been practiced. The difference between distress and wonder is often the difference between preparation and surprise. The body that the out-of-body experiencer observes from outside is not reported as foreign. It is recognized immediately as one's own. The face, the posture, the particular way the hands lie on the covers, all of it is familiar. What has changed is where the point of observation is. The body is still mine. The eye has simply moved to a vantage point from which it can see that it is mine. This is the body, seen from outside, still claiming its owner. Sleep is the condition the brain enters every night to restore what the day consumed. Glial cells expand. Metabolic waste is cleared through what researchers describe as the glymphatic system. Synaptic connections are pruned and reinforced. The hippocampus replays the day. All of this happens while the self is largely offline, its location suspended, its insistence quieted. The body does its most important work in the absence of the self. And the self steps back each night, and the body, unobserved, remembers what it is. The out-of-body experience has a quality that most altered states do not. It is experienced as more real, not less. The person who has one does not wonder if it was real. They wonder what its reality means, and that is a different kind of question. Neuroscience can describe the mechanism of the dislocation. It cannot yet describe what it means to have been both here and there, and to carry that particular dislocation forward. The meaning of having been somewhere else remains theirs to hold. The question the brain cannot fully answer about the out-of-body experience is the same question it cannot fully answer about ordinary consciousness. Why does neural activity feel like something? Why does the arrangement of electrochemical signals in the temporoparietal junction produce the sense of being here? Rather than simply processing the information, the out-of-body experience did not create this problem. It made it harder to ignore. The problem was always there, in the ordinary experience of being located in a body on this night, in this room, right where you are. The signals have all agreed again. The room is where it is. The body is where it is. The self, that continuous, effortful, ordinary construction, is here. The parietal lobe is integrating. The vestibular system has confirmed which way is down. What happened out there? In the space where the self briefly drifted, whatever it was, it brought you back. And here, in this particular agreement of systems, is a kind of rest that no longer needs to insist on its own reality. The brain is not certain what it is. It knows how to run. It knows how to build a world and a self and locate them in relation to each other. It does all of this without instructions, without effort, without being asked. But whether the experience it generates is the whole of reality or a window in it, remains a question it generates but cannot answer. You are hosted by a system that is still, in important ways, investigating itself. There is a particular kind of rest that comes from questions that have been held without being answered. Not the rest of resolution, but the rest of having stayed with something long enough to be no longer afraid of it. The out-of-body experience, whatever it is, has been held here in these facts. The science was real. The mystery was also real. Both of them can rest now. The self that wakes each morning does not remember the gap of deep sleep. The hours between the last waking thought and the first morning sensation are simply absent. Not dark, not empty, not anything. The self does not experience its own non-experience. And yet it returns, continuous, ready to begin again. Whatever the self is, it is resilient. The gap does not accumulate. Every morning is the same morning, in its most essential quality. The resumption of this particular experience of being here. The body has been keeping itself while you rested. The heartbeat continued. The breath continued. The neurons cleared and reset in the dark. None of it required the self's attention. The body knows what to do when the self is quiet. It has always known. The self is not the manager. It is, perhaps, something closer to the witness. And even the witness can rest. And the body continues. And everything that needs to continue, continues. The answer is not a location. It is not a hemisphere, a junction, a set of electrodes, or a disrupted signal. At the end of 100 facts about where the self lives, the answer is this. The self is what happens when the signals agree. And the grace of that, the daily grace of the systems maintaining their agreement, of the weight of the body on this surface, in this room, on this night, is not diminished by knowing how it works. It is more worth noticing. 100 facts ago, we were at an electrode, a precise point on the right temporoparietal junction, a current, and a person seeing herself from the ceiling. Now we know what was happening at that point. 3 systems briefly failing to agree. The self briefly appearing from the outside. The machinery briefly visible through its failure. We followed the rubber hand becoming someone's own. We followed the otolith crystals losing their input and the self beginning to drift. We followed the astronaut in microgravity, suddenly overhead. What began as a question about a neurological disruption became something closer to a question about what experience is for. The mechanism was never the whole of it. The experience was always pointing somewhere the mechanism cannot quite reach. The self is not separate from the brain that builds it. But neither is it simply its machinery. It is the agreement and the experience of the agreement, and something in that experience that has been finding this question worth asking for as long as there have been people to ask it. If these facts brought a little stillness to the questions you carry about the self and what it is, a quiet like or subscribe helps another curious, restless mind find this space. One quiet tap for everyone still searching for the way here. Right now, the temporoparietal junction is doing what it does. Not because you asked it to. Because the signals are arriving and the system is integrating them. And the answer, it is computing. You are here. This is your body. This is down, is already done. You don't need to confirm it. Let your entire being dissolve into that process. The quiet, continuous agreement of everything that locates you. It is already holding you. You can allow these thoughts to settle now, like signals that have completed their transmission and have nothing left to report. Let your body grow heavy with the agreement that is already in place. Sleep carries you to the place where the systems run without any witness at all, and the self, unfound, is finally, completely at rest. When you are ready, explore more of Mind Science in the Deep Sleep with Mind Science playlist, or in the video description below. But if your eyes are closed, stay there. Rest well, quiet one. The agreement holds, even in the dark, where science becomes the softest place to rest. Good night.